All right, so 2.2 part 2. So on Friday we talked about the end behavior of our graphs. So how our graph is going to start and how our graph is going to end. We talked about the arrows, if they go in the same direction, opposite directions. We also found the zeros. We found where our graph crosses the x-intercept. Next thing we're going to talk about is multiplicity. So multiplicity is a repeated zero. So sometimes in our answer we may get something like x equals 2 and x equals 2. This would be multiplicity because we have multiple of the same answer. It's a repeated zero. So when we have multiplicity, if our multiplicity is odd, meaning we have an odd amount of that answer. So if I had like only 1 x equals 2, or if I had 3 x equals 2, if there's an odd amount of that answer, then our graph crosses the x-axis at that number. If our multiplicity is even, so if there's an even amount of that answer, if I had just 2 x equals 2's or 4 x equals 2's, then our graph touches and turns at that number on the x-axis. So it touches but does not cross. Touches and turns. Or you can think about it as it bounces off the x-axis. So an example of these, if I had a graph, let's say I had x is equal to 2, and then x is equal to, we'll make it 4, and x is equal to 4. Something like this. These were my zeros. If I solved my equation out and got these 3 answers, when I graph them, I'd put a point on the x-axis at 2 and another point at 4. Let's just say our end behavior was down and then up, like this. At 2, since I only have one of them, my multiplicity would be odd. So when we have odd multiplicity, we cross the x-axis. So at 2, I'd go across the x-axis. Across the x-axis. At 4, we have 2 of them, so our multiplicity would be even. So here we touch and turn. So at 4, I'd touch that point and then just turn. It's like bouncing off of that point. You don't cross the x-axis at that point. You just touch and turn. So when your multiplicity is even, touch and turn. So this is kind of a little bit of an example to get you guys to see what it means to cross the x-axis and to touch and turn. We'll do a couple other examples where we work out the whole thing. All right, so in example 8, we want to sketch the graph. So first thing we want to do is find the zeros. So I'm going to cross out f of x, make it 0. And then we solve. How would we solve here? Awesome. We want to take out our GCF, so that would be x cubed. When we take out an x cubed, we're left with 3x minus 4. So now from here, we factored this as much as we can. We're going to set each piece equal to 0. So x to the third power equals 0, and 3x minus 4 equals 0. Now x to the third power equals 0 would just be x equals 0, but since it's x to the third power, we technically have 3 of them. This is like x equals 0, x equals 0, x equals 0. 3 of our x's are at 0. Which doesn't really change the point, but it does help us with the multiplicity. So it does tell us what we're going to do at that point. So I'm going to have a point at x equals 0, right at the origin there. And then my other point is going to be at, let's solve for x here. I'm going to add 4 to the other side and divide by 3. So x is equal to 4 over 3. 4/3, to help us graph it, it may be easier to either change it to a mixed number or change it to a number with a decimal, just so you can kind of see where this is going to be on the graph. 3 goes into 4 one time with 1 left over, so it'd be like 1⅓ or 1.3, just to kind of help you graph it. You don't have to change it to a decimal, but to see where it's going to be on your graph. So it's going to be a little bit past 1, so it'd be right there. Now let's talk about our end behavior. So our end behavior, we look at the term with the highest degree, so that is 3x to the 4th power. Is my exponent even or odd? Even. So does that mean that they go in the same direction or opposite directions? Same. Since 3 is positive, the leading coefficient is positive, are they both going to go up or both go down? What do we think? They both go up. It's like a positive parabola. It would open up. So both the arrows go up. So out of my point farthest to the left, I'm going to have an arrow that goes up. And out of my point farthest to the right, I have an arrow that goes up. Now we want to talk about what happens in between, how we're going to connect the dots here. So at x is equal to 0, is our multiplicity, well, how many of them do we have? We've got 3. So our multiplicity would be of 3, multiplicity of 3 at 0. This is how you would write it. I don't know if WebAssign's kind of picky about how it wants you to put it in. It might give you like blanks for it. But it'd be a multiplicity of 3 at 0. Is 3 an even or odd number? Odd. We have an odd amount of zeros. So this would be odd multiplicity. If our multiplicity is odd, do we touch and turn or go through? We go through. So I would go through the x-axis at 0. Now our other point was at 4/3, 4/3. How many of them do we have? How many 4/3 do we have as an answer? 1. So we'd have a multiplicity of 1 at 4/3. Is 1, is the amount of this answer, is it even or odd? Would 1 be even or odd? Odd. And if we have odd multiplicity, do we touch and turn or go through? We go through. So at the point 4/3, we're going to go through that point. So we just connect the dots there. So this would be our graph. If you were to find the exact answer of the graph, you probably have something maybe a little bit more funky happening down here. But we're just kind of doing a rough sketch of it. We just want to know, at our x-intercepts, do we touch and turn? Do we go through? And what does our end behavior look like? All right, on the next page, we've got 2 more. So for the following equations, we want to see our end behavior. We're going to graph it. We're going to find everything we just did, but we're going to graph it. So let's solve it. We want to find our zeros first. We're going to change f of x to be 0. How would we solve this? Grouping, awesome. When we have 4 terms, we'd solve by grouping. So I'm going to group the first 2, group the second 2. What's the GCF in our first group? X squared. What's the GCF in our second group? -4. When we take out an x squared, what are we left with? X plus 1, awesome. And when we take out a -4, we're left with x plus 1. So we got the same things on the inside, so we know that we grouped them correctly. So we're going to put the 2 outsides together. So x squared minus 4 and x plus 1. Can we factor this anymore? X squared minus 4. How can we factor that more? What would it factor into? What's special about it? Olivia. Awesome. So it's the difference of squares. So it would be x plus 2 and x minus 2. And we still have the x plus 1. So now that we factored everything all the way, we'd set each piece equal to 0. So x is equal to negative 2, x is equal to positive 2, and x is equal to negative 1. So if we were to graph this, we'd have a point at positive 2, negative 2, and negative 1. Next, let's describe our end behavior. So we look at our highest degree term to determine our end behavior. We have x to the third power. Is our exponent even or odd? Odd. So are they going to go in the same direction or opposite directions? Opposite. So now our leading coefficient is positive. So what does that tell us? What's the left arrow going to do? The left arrow goes down and the right arrow goes up. Since they go in opposite directions and our leading coefficient's positive, it's going to be like if it had increasing slope. So on my point farthest to the left, I put my left arrow, which goes down. Out of my point farthest to the right, I put my right arrow, which goes up. We just found our zeros, which are our x-intercepts. So that was x equals negative 2, positive 2, and negative 1. Now let's talk about multiplicity. Each one of the different zeros that we have has a different multiplicity. So we'll say at negative 2, how many negative 2's did we have as an answer? 1. So we have a multiplicity of 1. We'll answer the touch and turns on the next step. At 2, how many 2's did we have as an answer? 1. So again, we have a multiplicity of 1. And then at negative 1, again, we had a multiplicity of just 1. We only had one of them as an answer. So these are all odd. We only have one of them. So when we have odd multiplicity, do we touch and turn or do we go through? What do? We go through. So at all of these, we're going to go through. We can answer the next question. We go through. So let's do that on our graph. At each one of our points, we're going to go through. So at negative 2, I'm going to go through negative 2. I'm going to make my way over to negative 1. We're going to go through negative 1. And I'm going to make my way over to positive 2, and I'm going to go through positive 2. So my graph looks like this. Yeah, don't worry about the how many turns question. Any questions here? All right, let's do the same thing for the second one here. So first, let's find our zeros. What would we do to find our zeros? How would we solve? Awesome. We're going to take out a 2x. So when we take out a 2x, we're left with x to the fourth power minus 16. Can we factor this anymore?
Yeah, we can.
Yeah, what's special about x to the fourth power and 16?
They're both divisible in 4.
Well, it's the difference of squares.
Oh, okay.
They're both perfect squares, so it's a difference of squares. So just like we factored the one on the last page, it factors into its perfect squares. So what would go into our parentheses? Awesome. X squared plus 4 and x squared minus 4. Then we still have that 2x on the outside. All right, now do any one of these factor more? X squared minus 4 can be factored more because it's the difference of squares. So only difference means subtract. So only the ones with a minus sign in the middle can be broken down more, can be factored more. So x squared minus 4 factors into x plus 2, x minus 2. So again, difference means subtract. So only when you're subtracting your perfect squares, you can factor it more. That x squared plus 4 can't be factored anymore. So now that we've found all of our factors, we can set each piece equal to 0. So we have 2x equals 0. How would I solve here? There's a question like this on one of the versions of the test that kind of confused people. How would we solve? Divide by 2. And what's 0 divided by 2? 0. Awesome. Next, we have x squared plus 4 equals 0. I'm going to subtract 4 on both sides, so x squared equals negative 4. Take the square root. Can I take the square root of a negative? No. So here, we actually don't get an answer. This is imaginary. So it goes away. We don't have, it doesn't touch the x-axis here since it's not a real number. So it's not going to be one of our zeros. At x plus 2 equals 0, what would x equal? Negative 2. And x minus 2 equals 0? Positive 2. Now let's describe our end behavior. So we're not going to worry about how many terms. Let's talk about our end behavior. If we have 2x to the 5th power, is 5 even or odd? Odd. So odd means that they go in the same direction or opposite directions? Opposite. Odd is opposite. And our leading coefficient's positive, so what does that tell us that our left arrow is going to do? Left arrow goes down, right arrow goes up. Our overall slope of our graph would be increasing. So let's put those on our graph. We're going to put our zeros on our graph too. So I'm going to have a point at 0, a point at negative 2, and a point at positive 2. Then I can do my end behavior. So out of my point farthest to the left, I have an arrow that goes down. Out of my point farthest to the right, I have an arrow that goes up. Our zeros we found up top, we had x equals 0, x equals negative 2, and x equals positive 2. Do we have any zeros that repeat? No. How many x equals zeros did I have? How many x equals zeros? Just 1. So at 0, we have a multiplicity of 1. At how many x equals negative 2 do I have? 1. So at negative 2, we have a multiplicity of 1. And then at positive 2, how many positive 2's do we have? Multiplicity of 1. So now for our multiplicity, we're talking about how many of them that we had. So is 1 an even or odd number? 1 is an odd number. So if we have odd multiplicity, do we touch and turn or go through? We would go through the x-axis. So at each one of our points here, we're going to go through the x-axis. So at negative 2, I would go through the x-axis. At 0, I go through the x-axis, and at 2, I go through the x-axis. So my graph would look like this. These questions go with 18 through 22 on the WebAssign. I took them off of the WebAssign, but if you already downloaded it or if you already opened it up, you'll probably see the 18 through 22 still there. You might have to refresh. I'm not sure how it works on WebAssign because I just deleted the questions this morning. So you only have 17 questions on the homework. 17 questions. So you're only doing 1 through 17. So numbers 1 through 17. So if your 18 through 22 are still there, just skip them. Don't do them. I'll look at the score without them. So don't worry about getting that 85% if these 5 questions don't get you there. But just make sure you do 1 through 17. So you're skipping 18 through 22.